We might need a few more candles for the moon's birthday cake, with radiometric analysis revealing it to be at least 4.46 billion years old. Trending-related articles. Fresh analysis of lunar dust brought back to Earth by Apollo astronauts has revealed that the moon is some 40 million years older than was previously thought. Scientists believe that the moon was formed roughly 4 billion years ago, when a body the size of Mars, dubbed Theia, slammed into the infant Earth. This impact ejected a large amount of material into orbit, some of which went on to coalesce and form the moon. Exactly when this happened, however, has remained unclear. L equals document.create element script.l.set attribute src https://live.premies.text/live/liveview.php.s equals 114945 player API ID equals v114945.document.get element by ID of premies.appendchild L. The new study involves the dating of crystals found inside samples of lunar dust collected on the Moon in December of 1972 by the Apollo 17 mission. Radiometric dating of these crystals reveals that they formed 4.46 billion years ago, meaning that the Moon, which formed before the crystals, must be at least this old. Read more. Most comprehensive view of the universe's history drawn up in 2 charts. The study was undertaken by cosmochemist Professor Philip Heck of the Field Museum in Chicago and his colleagues. The researchers explained that when Theia collided with the Earth, the energy of the impact melted the rock that would eventually become the Moon's surface. Heck added, when the surface was molten like that, zircon crystals couldn't form and survive, so any crystals on the Moon's surface must have formed after this lunar magma ocean cooled. Otherwise, they would have been melted and their geochemical signatures would be erased. These crystals are the oldest known solids that formed after the giant impact, and because we know how old these crystals are, they serve as an anchor for the lunar chronology. In this way, determining the age of the zircon crystals can give a minimum possible age for the Moon. To date the crystals, the team used an analytical method known as atom probe tomography. Paper co-author and cosmochemist Dr. Jenica Greer, now based at the University of Glasgow in Scotland, explained, we start by sharpening a piece of the lunar sample into a very sharp tip, using a focused ion beam microscope. Then we use ultraviolet lasers to evaporate atoms from the surface of the tip. The atoms travel through a mass spectrometer, and how fast they move tells us how heavy they are, which in turn tells us what they're made of. This atom by atom analysis allowed the team to determine how many of the atoms in the zircon crystals had undergone radioactive decay. Heck added, radiometric dating works a little bit like an hourglass. In an hourglass, sand flows from one glass bulb to another, with the passage of time indicated by the accumulation of sand in the lower bulb. Radioactive dating works similarly by counting the number of parent atoms and the number of daughter atoms they have transformed to. The passage of time can then be calculated because the transformation rate is known, based on the ratio of parent-daughter isotopes found in the zircon crystals. The team have determined that the sample is around 4.46 billion years old. By extension, the Moon must be at least 4.46 billion years old. If not older, Greer said. It's amazing being able to have proof that the rock you're holding is the oldest bit of the Moon we've found so far. It's an anchor point for so many questions about the Earth. When you know how old something is, you can better understand what has happened to it in its history. According to Heck, it is important to understand exactly when the Moon formed, because the Moon is an important partner in our planetary system. Heck added, it stabilizes the Earth's rotational axis. It's the reason there are 24 hours in a day. It's the reason we have tides. Without the Moon, life on Earth would look different. It's a part of our natural system that we want to better understand. And our study provides a tiny puzzle piece in that whole picture. The full findings of the study were published in the journal Geochemical Perspectives Letters.